Hello, good evening. So, welcome to the session of Parabola. And in this session, we will discuss some more properties of tangents, okay, about the point of intersection, and also we'll see what is chord of contact. So, let's go ahead. So, point of intersection of tangents. So, the intersection of point of intersection of tangents. Imagine that I have a parabola here. Right? This is a point here, P, which is a t1 square, comma 2a t1, and this is my point say q a t2 square comma 2a t2. So tangents are drawn from these 2 points, like this and like this. They are of course going to intersect. Okay. So we are interested in knowing the point of intersection of these two tangents. So what is this? So let tangent at point PB, tangent at point PB, we have seen here. So it's going to be yt is equal to x plus at square. This is the equation of tangent. At a point P on the parabola, y square is equal to 4ax. So now this is point T1, so I'll be writing it yt1 better. And tangent at Q. So tangent at QB, so I'll be having yt2 is equal to x plus a t2 square. Now I want to find out these coordinates, x and y, where do they intersect? So to find the point of intersection, we need to solve both these equations. So solving 1 and 2 for the point of intersection. Solving 1 and 2 for the point of intersection. So if I want to solve this for point of intersection, so I'll be subtracting them. So of course, this is y, and then t1 minus t2 will be right here. And I can see that x gets cancelled. So this will be a into t1 square minus t2 square. So obviously here t1 is not equal to t2. That means I can cancel t1 minus t2. So y is equal to a times t1 plus t2 I get. So y is equal to a times t1 plus t2. Now this y I can plug it into any of the equation to get my x. So therefore I can just plug it into any of the equation. So I have here a into t1 plus t2 into t1 is equal to x plus a t1 square. So this will give me a t1 square is equal to a times t1 t2 is equal to x, sorry, not is equal to plus. This is plus basically. Plus a t1 t2 is equal to x plus a t1 square. So I see my a t1 square gets cancelled and I get x is equal to what? A t1 into t2. So this is the point of intersection, which I get as what? A t1 t2 comma a times t1 plus t2. So this is my point of intersection. I'll rewrite it. It's not really clear. Okay. T1, T2, comma. We can write like this. T1 plus T2 over 2. Now if I write it down, then it is quite obvious if you see here carefully. Upon 2 I can write down. So which is actually, if I write down here a T1, T2. So if I have here T1 square into T2 square, then this is nothing but the, if I take a outside. So I have here T1 into T2, comma, 2 times okay, T1 plus T2 by 2. So this is nothing but the geometric mean of abscissa. Geometric mean of abscissa of these 2 points. Okay. So let's just take the inside. So if you take inside here, basically, then have here at1 square and this is at2 square. So if I find out the geometric mean of these 2 numbers, so geometric mean is going to be what? At1 square and at2 square. So I'm going to have here a times t1 into t2. So this is the geometric mean, and this is nothing but the arithmetic mean. So 2 times the arithmetic mean. This also we can have. Now, so let's see the special note. So from this only we get another result. So note. So if P and Q are the extremities of focal chords, are extremities of focal chord, or say you can say an endpoints of the focal chord, so endpoints of the focal chord, endpoints of the focal chord. Then we know that T1 into T2 is equal to -1. From the very result, we already have proved that tangents, T1, if I have a parabola and this is my point P, parametric point T1, and this is Q, parametric point T2. Then T1 into T2 is -1. So that means if I know one end of the focal chord, then I know the other end. So if I use this result, then point of intersection of tangents. So point of intersection of tangents at P and Q is going to be what? I'm going to have here A times T1 comma T2 comma 2 times T1 plus T2. 2 A times. In fact, this one is not required. I will just turn on simply 8 into T1 plus T2. Looks good. And then here T1 into T2 is -1, so I can plug in here minus A comma A times T1 plus T2. Now one can see here clearly that this is my x coordinate basically. So x is equal to -a, which in turns out to be the directrix of the parabola. Directrix of the parabola. So what is the result? That so the result is tangents drawn at the endpoints of focal chord. Focal chord intersect at the directrix. Intersect at the directrix. So tangents drawn at the endpoints of focal chord of parabola intersect at the focal chord of parabola intersect at the directrix. So this is one result. Now in this result only we observe something very special, that my if tangent at equation of tangent at P is what? Y T1 is equal to x plus a T1 square. So if I take this equation and rewrite it like this, so y is equal to 1 over T1 into x plus a T1. And this a tangent is 1 over T2 into x plus a T2. So the slopes of these tangents, okay, slopes of these tangents, if you watch carefully, the slopes of these tangents also, the slope of these tangents, that is tangents at P and Q. Slope of these tangents at P and Q. It's going to be what? 1 over T1 and 1 over T2. So if I take that product, so M of tangent at P into M of tangent at Q is going to be 1 over T1 into 1 over T2. So this is 1 over T1 into T2, of course. So this is -1 because T1 into T2 is -1. That means I see that MP into MQ is equal to what? -1. So this implies these tangents are perpendicular. So these tangents are perpendicular. That means now we have another result. The result is what? Tangents drawn at the focal chord of the parabola, drawn at the endpoints of the focal chord, they intersect at the directrix. And not only this, in fact, they are perpendicular. So if someone asks me that locus of point of perpendicular tangents, result 2. So point of locus of the point of locus of the point of intersection of perpendicular tangents. is the directrix of the parabola. Is the directrix of the parabola. This is a very important point. So that means if I have, that means directrix can be considered as the locus from where perpendicular tangents are drawn to the parabola. So that means if I take any point and here if I draw the tangents to this parabola, that means these two tangents are going to be what? Perpendicular. So, and if tangents are drawn at the focal chord, then they are of course they are perpendicular. And the point of intersection of tangents basically at P and Q is nothing but the directrix of this parabola. So this is these are the two results which we had. Okay, so I hope this specifies and you understood this. Now let's take the another section. Now we will see the chord of contact. The chord of contact is going to be we have here the tangents at P and Q. So this is my point P and this is my point Q. So if I draw a line segment which joins P and Q, then this is called as the chord of contact of tangents. Chord of contact is going to be a line segment joining the point of contact, a line segment joining the point of contact of tangents to the parabola at two distinct points. So line segment joining the point of contact with tangents to the parabola at two distinct points. That means so suppose if I have an external point, then from a very definition of, not definition, in fact, from a very powerful result that we have seen so far, not we have, in fact, we might have seen. So for a, if I have a 2-degree conic, then from an external point, okay, two tangents can be drawn. So these are my two tangents. Now these two tangents are going to touch the parabola at P and Q. So the line segment joining the point of contact of two tangents, okay, to the parabola at two distinct points. Okay, is nothing but my chord of contact. So a line segment join the point of contact of two tangents to the parabola at two distinct points. Is nothing but my chord of contact. Now our goal is to get it. That how do we get the equation of this P and Q? So now we can take this way. So this is my point P. Of course, this is going to be 8t1 square comma 2at1. And point Q is 8t2 square comma 2at2. And say this is my point R. Okay, say H comma K. So the point of intersection you could say of tangents, or you say from this point two tangents are being drawn to one and the same thing. Moving ahead. So what I'll do, I'll write down the equation of tangent at P. So equation of tangent at P is, so equation of tangent at P will be, whether instead of taking the parametric point, we can even take it x1, y1 also, no problem. Because ultimately we don't have to work anything with the parametric coordinates here. So I'll be taking x1, y2, x1, y1, and x2, y2 for convenience. So equation of tangent at P x1, y1 is y1 is equal to 2a into x plus x1, and tangent at Q, and tangent at Q, which is x2 comma y2, is what? y2 is equal to 2a into x plus x2. These are my two tangents. Now, of course, they pass through a common point, which is R. That means they're intersecting. So our goal is not to find the point of intersection because we already have done it. So this is my point 1 and this is point 2. Now, since they meet at point R, since they meet at R, which is H comma K. So this implies K into y1 is equal to 2a into x, which is h plus x1. That means this tangent is going to satisfy this point. I'm sorry, point will satisfy the tangent. Please let me correct myself. This is x and y, so I'll be just plugging here. ky1 is equal to 2a into h plus x1. And similarly, this point, this line, this is going to be what? ky2 is equal to 2a into h plus x2. Now, from these two, if you notice, okay, from these two, if you notice, then this k becomes fixed, and now this y1 and y2 are varying. That means this is the equation of a line, basically. So this is the equation of line, which is the equation of line. This is the equation of line. So which line I can write down now? So if I choose this y1, y2 as variables, so I'll be having here k into y is equal to 2a into x plus h. This is what I'm going to have. So equation of chord of contact. So that means equation of chord of contact, if I have to write down, so just I need the point. So therefore, so equation of chord of contact, equation of chord of contact with respect to a point we could write just for convenience with respect to a point. Say h comma k. So I can write down the equation of chord of contact as ky is equal to 2a into x plus h. So I have the chord of contact. In fact, if I solve the chord of contact and parabola, so I get the point of contact of two tangents. No. Locus of midpoint of chords. Locus of midpoint of chords. Or you say equation of the chord whose midpoint is given. Whose midpoint is some p, say x1, y1. That means I have a parabola, you can imagine. And now there is a chord here given, and its midpoint is given to be, say, x1, y1. So I want to find out the equation of this chord. And say this is my point. Midpoint I already have given. So midpoint I'll write down better with some other notation, say n. And now so this is my point P, and this one is my point Q. This is my point N. So P we can write down for simplicity x2, y2, and Q we will take x3, y3. Of course, this chord will intersect at the parabola at 2 points. So I have just taken those 2 points as P and Q, and I have the midpoint of chords here as x1, y1. Now I want to find out this thing. So we can write down slope of PQ. Because I have the point, I just need the slope. So slope of PQ is equal to what? Y2 minus y3 upon x2 minus x3. And now we know that y2, y3 both are on the parabola. So they satisfy the equation of parabola. That means also we know this thing. They're on the parabola, so I'll be having y2 square is equal to 4ax2 and y3 square is equal to 4ax3. This I know. So when I have taken y2, so if I subtract these two, then I'll be having y2 minus y3 into y2 plus y3, because this is going to be a square minus b square. So here I can take 4a common. So now I have x2 minus x3. Now y2 plus y3, if we watch carefully, then we know that x1, y1 is the midpoint of p and q. That means y2 plus y3 should give me 2y1. So y2 minus y3 is equal to, this is 4a over y2 plus y3 will give me, see this is the midpoint. That means I can write down y2 plus y3 upon 2 is equal to y1. So I'm going to have here 2y1 into x2 minus x3. That means I know the slope. So therefore, this y2 minus y3 over x2 minus x3 is nothing but 2a upon y1. So therefore, equation of the chord passing through, the equation of the chord passing through, what's the point here? So yes, x1, y1, and having slope, and having slope. Slope is going to be 2a over y1. 2a over y1 is. So of course, y minus y1 is equal to 2a over y1 into x minus x1. Now we can multiply. So this will be y1 minus y1 square is equal to 2ax minus 2ax1. Now we just need to add few terms because we can see here that if I add a y1 square is equal to 4ax1 is nothing but the point on the parabola. So I can write down s1 here, and y1 is equal to 2a into x plus x1 is nothing but the equation of tangent. So y1 already had. So y1, I'll just simply subtract here 2a into x plus x1 and is equal to y1 square. I'll take it here, and then I have plus 2ax minus 2ax1. Since I have added this part here, so I'll be subtracting here also. So minus 2ax minus 2ax1. So this is nothing but y1 minus 2a into x plus x1, and here I'll be having y1 square. And then uh, this part will get cancelled, and I'll be having here minus 4a x1. So this is nothing but the equation of tangent, and this is nothing but s1. So t is equal to s1 is nothing but the you could say locus of midpoint of chords. You say equation of the chord whose midpoint is this, or you could say the equation of, or you could say locus of midpoint of chord. Anything, whatever comes to your mind. I think we can say this. So we have found now the locus of midpoint of chords. So we can say this one. So find the equation of tangent to the parabola y square equal to 16x, which are perpendicular to 2x minus y plus 5 is equal to 0. So I have y square is equal to 16x. So this implies 4a is equal to 16. So from here I get a is equal to 4. So equation of tangent is, so equation of tangent having slope m. We can write down having slope m is y is equal to mx plus a by m. So this implies I have y is equal to mx plus a is 4 over m. Now, since slope of this line is 2x minus y plus 5 is equal to 0 is 2. So therefore, slope of the tangent is minus 1 by 2. Because my slope is, my tangent is perpendicular to this line. So therefore, m is equal to minus 1 by 2. We can directly plug in here. So y is equal to minus 1 by 2x plus 4 over minus 1 by 2. So this gives me y is equal to minus 1 by 2x minus 8. So I'm going to have here 2y is equal to minus x minus 16. Take it here. So x plus 2y plus 16 is equal to 0. This is the required equation. Moving to the next. Here, you can pause the video and try to solve this question on your own. This states that if two lines are drawn from a point P to the parabola y square equal to 4x are at right angles, then the locus of P. So of course we know that this is my parabola y square is equal to 4x, and tangents drawn from this point, they are at right angles. That means tangents are what? Perpendicular. So if the tangents are perpendicular, then this locus of this point is going to be the directrix from the result which we have derived. So this is focus is what here? 1 comma 0. That means directrix is going to be this line, which is x is equal to minus 1. So this you could answer directly. In fact, a similar question can be seen even in JEE here, and you must try to answer this. Okay, so the two tangents are drawn from a point P to the parabola are at right angles. So you can shift x minus 3 to be capital X. So you get y square is equal to 16x. So locus of the point, that means we need to know the directrix. So of course, you have y square is equal to 16x. So this point is basically 4a is equal to 16. So a is equal to 4. So this point is basically 4 comma 0 for the new parabola. So that means for shifted parabola, so for shifted parabola, we know what is the focus. This is 4 comma 0. Parabola is shifted to what? 3 comma 0. So we can just add it. Focus is 7 comma 0. Or instead we could have done nothing. This is 4 comma 0. So we could have written the directrix directly. So directrix is going to be x is equal to -4. So directrix x is equal to -4. That means we want in small x. So capital X is what? X minus 3 is equal to -4. That means x plus 1 is equal to 0. So we get the equation of directrix, and that's what is required. Okay. We'll see you in the next section. Thank you so much.